How does your iPhone know your face is your face when you turn it on? How does it predict whatever you want to say when you type something? And how exactly does it get Google Translate to read all of these sentences that you type in? The answer is neural networks, specifically artificial, convolutional, and recurrent. But how exactly do each of these three different networks operate? Let's have a look. If we look at artificial neural networks, which are the type of networks that you want to use if you want to perform facial recognition. So, this is a type of algorithm that has multiple perceptrons connected to each other at each layer, making it one of the simplest. And they may not even have hidden layers. And because of their straightforward structure, they have a distributed memory and can store information on the entire network and are even able to work even with incomplete knowledge. However, they are very highly dependent on their hardware and sometimes unexplained behavior may occur. Let's now have a look at convolutional neural networks, and these are the networks that are responsible for both reading your face and also predicting what you want to say next when you type in your Google. So basically, this network is more complex than the artificial neural network because they use a variety of multi-layer perceptrons, and they also have convolutional layers that can either be entirely connected or pooled. And because of this, they have a very high accuracy when it comes to image recognition, and they also share weight and parameters, making it a very efficient network. However, because of this, a lot of training data is required, and it's also one of the most expensive types of neural networks to train. Finally, let's have a look at recurrent neural networks. Unlike their cousins, recurrent neural networks are some of the most complex, and they are able to store in the memory in their output nodes, meaning they have something called long short-term memory, which puts them at a huge advantage. And this is how they're able to remember whatever you type into Google Translate as well. However, because of this exact property, training RNNs can be an extremely arduous task, and it cannot process very long sequences with certain activation functions, such as tanh and ReLU. And there you have it, the three different types of neural networks that are currently used today. In the future, as AI gets more and more efficient and more advanced, we'll be seeing more of these types of neural networks into use. Thank you very much for listening. Bye-bye.